In this video, we will talk about network address translation, NAT. Okay, so network address translation, that is a method of remapping one IP address space into another by modifying network address information in IP datagram packet headers while they are in transit across a traffic routing device. So the main usage of NAT is to limit the number of public IP addresses on an organization or company must use for both economic or security purposes. So why we need NAT? The first one is NAT allows multiple devices on a private network to share a single public IP addresses. Okay, so that helps to conserve the limited number of available IP addresses. Secondly, by hiding internal IP addresses from outside world, NAT adds a layer of security. External hosts cannot directly reach to internal devices. That reduces the exposure to attacks. Okay? The third one, NAT enables easier management of IP addresses and facilitates the integration of new devices into the network without requiring public IP address assignments. And finally, NAT allows organizations to use private IP addresses internally, which can be reused in different networks, enabling better scalability and flexibility. So a private IP address is an IP address that is reserved for internal use behind a router. Okay, so apart from the public. So private IP addresses are not routable in the internet. Okay, in the public networks, they are not routable. So private IP address ranges are class A, class B, and class C, and class A is this range, class B uses this range, and class C uses basically this range. So only thing that you need to memorize about the private IP address range are their classes. Also, please make sure not to forget they are not routable in the internet. So there are some terms help us to clarify how NAT translates and manages IP addresses between internal networks and the external internet, enabling seamless communication while conserving IP address space and enhancing the security. They are inside local, that is the private IP address assigned to a device within a network, okay? That will be your host IP most of the time. We have the inside global. This is the public IP, okay? That is assigned to a device when it is translated for external communication. So that is your public IP. We have outside local term, that is the IP address of an external device as it appears to the local network. Okay, and that is the remote host IP basically. And we have the outside global. So this is the actual public IP address of an external device on the internet. Okay, so that is the remote public IP. So how we can check it in here? For example, I have my PC1 and it is assigned to 10.41.1.5. That is the inside local IP address from this router perspective. We have the inside global, that is 6.2, that is your public IP. we have the outside local 3.5 for this case, that is the remote host IP address, and we have the outside global that is here, that is the remote public IP address. So for NAT types, we have three types: static NAT, dynamic NAT, and the path. In static NAT method, guys, the private addresses are matched with global addresses 1 to 1. So for example, I have this IP address, this IP address, and this IP address, and they are all belonging to PC1, PC2, and PC3. So when PC1 is reaching to the public network, public internet, this IP address will be mapped to this IP address, okay? And this IP address of PC2 will be mapped to this IP address, because these are all private IP address ranges. They are my inside local, and these IPs cannot be used in internet. They are not routable through the internet. That's why I am changing my private IP as this public IP, and in static NAT, that is like a one-to-one mapping. For each and every private IP address, I am using one public IP address, okay? And we have our dynamic NAT method. In dynamic NAT method, there is a public IPv4 pool that is configured on a router, and IP addresses are assigned with first come, first served rule. So for example, if PC1 needs to browse on internet and this guy is making the NAT, then this IP address will be converted as this IP address. But then if the second one is the PC3 who is trying to reach the internet, then this IP address will not be mapped to this IP address as it is PC3, and it will be mapped to this IP address as 36, since this PC is coming second. And if PC3 will be the one who is trying to reach internet, PC2 is the one who is trying to reach the internet in the third sequence, then it will obtain the IP address of 37. So it is first come, first serves rule for dynamic NAT. And we have the path option. In path option, each private address is translated to a single or just a few public IPv4 address, and port addresses are used for choosing the right internal device when the packet is coming back. Okay, here I have this IP addresses still coming from PC123, but all of them will be using these IP addresses as a source IP when they are browsing the internet. So when the packet is coming back, the port numbers will be used as differentiator to send the packet to the correct destination. So guys, when I'm doing the NAT configuration, let's start with the static NAT configuration first. So when I'm doing the static NAT configuration, the commands I'm using is ipnat inside and source static. Then I'm putting my private IP address and putting the public IP address that I want to match this private address space. Okay, so 11 it's mapped this 35, 12 it's mapped with 36, and so forth. And then what I'm doing, I'm going ahead, I am just going ahead to my gig00 interface, which is this interface for this router, looking to my local area network. And then I'm assigning an IP address for this interface, and the command I am using is ipnat inside. And then I'm going to my other interface in here for gig01, and what I'm doing is I'm assigning an IP address again. As you could see, I'm assigning an IP address in here to my gig01 interface, as you could see in here, and I am typing ipnat outside for the interface which is connecting to the internet. How I can verify it? Show ipnat translations. It will show you whichever IP address you are using as inside local and whichever IP address is being used as inside global. It will show you the mapping, and you can verify if the mapping looks correct or not. And dynamic NAT configuration. If you remember, there was a pool within the dynamic NAT configuration where the PCs use on a first come first use basis. Okay, so first of all I need to define an IP pool. Okay, so the definition is like ipnat pool. I'm giving a name for my pool, then I am defining the IP address range for this pool. For this example, it is from 35 until 38, you can see in here. Then I am assigning the net mask. I am assigning basically this subnet mask that I want to use for my public IP space. Then I am creating an access list. Okay, access list 10 permit, and I am defining my internal network IP address space. Okay, remember, when you type an condition like this 1041.10 with this wildcard mask, that means just have a look to first 3 digits. In this case it will be 1041.1. Okay, then ignore the last bit. Then what I'm doing, I'm typing ipnat inside source list 10. 10 is the access list number I'm using in here, and pool followed with the IP pool that I created, which is network L for this case. Then when I'm defining all these parameters related to my ports and an access list which is showing my which is basically to match my internal address usage, then I'm going ahead to my gig00 interface. I'm assigning my IP address and typing the command ipnat inside, and I'm going to gig01 interface and I'm assigning the IP address, as well as I am typing ipnat outside command. That's it. On the other hand, we have path configuration. As you know, this is how I'm doing the path configuration. Okay, again I need to define a pool, but this time, most of the time, there will be a single public IP with the path itself. Okay, so the configuration is again ipnat pool and the name of the pool, which is network L path for this case, and then I'm still defining my range. For this case, I'm putting the same IP addresses because I will use a single public IP address only. You might define a FIV also, just keep in mind that, but most of the time it will be just a single IP address followed with a net mask of this one, okay, subnet mask. Then again I'm defining an access list 1 permit and 1041.10 with 000.255 wildcard mask. that is to match all of my PCs in my internal network, that will match all IP addresses starting with 10.41.1. Then the command is IP not inside source list and access list number pool network help path followed with overload keyword. Okay, that is the key differentiator for path configuration. And then what I'm doing, again, I'm going to the each and every interface. For internal interface, I'm typing IP not inside. For external, I'm typing IP not outside. So when it comes to NAT for IP version 6, IP version 6 has a huge address space, guys. So there is no need for NAT for private public translation in an IP version 6 environment. So NAT is only used for communication between IP version 6 and IP version 4 and IP version 6 devices, and this method is known as NAT64. So we are coming to end of this NAT session as well. Thank you so much for joining me, and let's meet in the other lessons.